Okay, now we're going to extend limits to look at rate of change. If you want to find the instantaneous rate of change at a point, that is called a derivative. And how we do that is we're going to use this limit definition here. And what this basically does is it uses your average rate of change, which is subtracting 2y points over 2x points. Here though, our y points are going to be our location plus a little bit more added on. So when we do that, now our equation becomes your f value, or your function value at that point plus a little bit more, minus that point we're looking at, over those same two x values. And when you do that, these x values of a are always going to cancel out, and so that's why we only see h on bottom here, but we got the difference of our y values on top over the difference of our y or our x values on bottom. And if we now take the limit as that little bit extra h goes to 0, then we find the instantaneous rate of change at that point. Down here is a second limit definition of derivative that can also be used when doing it at a point, and it works similar. Okay, so let's see, apply this to an example. Find the derivative, and this is derivative notation that you've seen before, of the function by using the limit definition here. So what we're going to start out doing here is we're going to do what's the limit as our little bit extra h goes to 0 of our function at that little bit more. So what we want to find here is what is this function at t plus h minus our function right at t over, and again we're doing t plus h here minus t, but those t's cancel, so this bottom's just going to become h. Okay, so now let's fill in what those two functions are. So our function on top, if we plug in t plus h for both of our two t's here, this t and this t, so we're plugging in t plus h for both of those, what this is going to become then is f at, 5 times t plus h minus 4 over, now we're putting t plus h in for that other one, t plus h plus 2 minus, now this next one here, this is just our function here, so that function is just this this function over here, so it'd be 5t minus 4 over t plus 2, and then our whole thing still remains over h. All right, now our goal to solve that now goes to some of those limit things you did before, and that's why we practice those. This one looks like we should be able to maybe just simplify and get to our answer. So some simplifying to start with here is that we could look to, since we got two separate denominators here, this denominator and this denominator, let's look and see if we can get a common denominator between these two fractions. On our top here, we got, I'm going to distribute that 5 over this. But I'm going to multiply this one now by our other denominator of t plus 2 and t plus 2 minus this. But I want to multiply by our other denominator here of t plus h plus 2 and t plus h plus 2. And we want to get that common denominator, and this is still all over h. So we got some distributing to do here. Let's see if we can do it. So everything in these two needs to be multiplied to each other. So start with the 5t and multiply it to t, and then this times t, and this times t, and then everything times 2. And so we're going to end up with 5t squared plus 5ht minus 4t. And now we multiply everything by 2, so 10t 10h minus 8. And that's all over our common denominator here of t plus h plus 2 and t plus 2. Those ones I'm not going to multiply, and you'll see why later. All right, now over on the other side, we want to distribute through here. Before we do that, though, we got this negative. I'm going to distribute that first before I distribute that. So what that's going to make this here is then that this really is going to become plus negative 5t plus 4. So I'm going to distribute that to our other term over here and get some more stuff here. So we're going to end up with minus 5t squared minus 5ht minus 10t. And now multiply 4 through by everything, so plus 4t plus 4h plus 8. And this is all still over in h. All right, so we should see some stuff hopefully simplify here. Some things we can cancel out. Those 5t squareds cancel out. This 5th cancels out. The 10t's cancel out. The 4t's cancel out. The 8's cancel out. And I think that looks like everything. So now our limit becomes a lot clearer here. Now on top we just have 10h plus another 4h, so 14h over this denominator that we have. And then it's all over this other h. Instead of putting it all over h, let's multiply by that reciprocal of 1 over h. And so what cancels here? That cancels, that h cancels, and now our limits become even better here. So now we just have 14 over this. And now that we don't have dividing by 0 anymore with that h, we can plug in 0 in for h here and simplify. So now we simply have 14 over t plus 2 times another t plus 2. That's the answer, or we could simplify that even further. If we got two of the same things, we could write that as t plus 2 squared. And so that right there would be our derivative. The notation that we've used in the past on that is to write this as that f prime of t would be equal to 14 over t plus 2 squared. And as we get into this, we'll kind of review some of those shorter cut methods, but that's limit definition. You should have a working idea of how to do limit definition of derivative. Let's try one more together and then have you guys try one. This one involves a square root. So again, you want to do what's the limit as h goes to 0 of our function at t plus that little bit h minus our function at t all over that little bit. What's our function at t plus h? In this case, that would be square root of 7 t plus h minus 1. Minus is our function of 7t minus 1 all over h. On this one, we got to, again, try to figure out this. We can't plug in 0 right now. I don't think we can just simplify with those square roots. Go back to those different ways. There's no factoring to do, but with square roots, oftentimes like this becomes a conjugate problem. And we are going to want to do a conjugate here. So we're going to do multiply by the same thing, but change that sign in between to plus. And whatever we multiply on bottom, we also got, or top, we also got to multiply on bottom here. All right, so what does this now look like for our limit? Well, on top, if we multiply those first two radicals, that just basically gets rid of the radical sign. So now it's going to be 7 times t plus h minus 1. Now those middle, or those outside middle ones should cancel if we were to FOIL this through. If we multiply those last two radicals, it's going to end up being negative. and then we'd have 7t minus 1 as the stuff left. Notice I did put that in parentheses because there is a subtraction sign in front of that. And then on bottom we have that h, but we also have these two other radicals now with that. Okay, next thing now, what we want to do is see if on top some of that stuff might cancel out. And I think we do get some canceling here. So I'm going to distribute that 7. I'm also going to distribute this negative sign here, just like I distributed the 7 over there, and we get this. It looks like we are going to get some stuff canceling here. So now looks like this. Should be minus 1. And then next step, what we want to do is try to simplify even more. So now our top just becomes all that's left there after we cancel out looks like it's just that 7h. And what we can further simplify here is canceling out that h. And so now we don't have that division by 0. We should be able to plug in 0 for the remaining h's, which is just going to give us 7 on top. On bottom here, we got the square root of 7t plus 0 minus 1. And so that's going to simplify to just 7 over square root of 7t minus 1 plus another square root of 7t minus 1. That's an okay answer, but if we're adding two of the same type of radicals, that means that we have two of those now, so we could write it as 7 times 2 times square root of 7t minus 1. And that would be our derivative. All right, let's have you try one now. See if you can pause the video and find the derivative of this one. All right, if you did your limit here as we approach 0 of our function here, f of x plus that little h minus our function at that all over h. Substituting in here then, you're going to have, this should end up being x plus h. You got to put x plus h in for both this variable and this variable. Plus 9 minus our original function, and notice I put that in parentheses here because we're subtracting, so we're going to need to subtract all that over h here. A little bit of simplifying on that first one there. So this part, we're going to need to multiply two of those out, and here we're going to need to distribute. So let's see what we come up with. X plus h times another x plus h is going to be x squared. When you multiply the inside ones, there's going to be an xh plus another xh, so 2xh plus h times h is h squared. Distributing that negative 8, we get this. And then here we're going to have to distribute through that negative throughout all these last terms. So if we do that, we get this all over h. And this parentheses really is not doing anything because there's a minus after, so I'm just going to take that out. All right, so what do we get simplifying here? Our x squared should cancel. These 8x's should cancel. These 9's cancel, and I believe that's it. So now let's write what's left in our limit. And everything left here after we write this out, you can see does have an h in. So then our next step, like we've done before on problems, factor out that h. And we're almost to our answer here. Now these cancel, and now we can plug in 0 for the remaining h. and we come up with our derivative of 2x minus 8. So that would be our derivative of this problem. And going back to last year, if you remember some of our quick derivative rules, which we will review coming up, you should remember our little power rules about bringing that down. And that would end up being 2x minus 8. And I remember derivative of a constant 0, so that is the same answer we got with our quick derivative rules. But it's good to know that working definition of limit of derivative, limit definition of